Welcome to a new video in my home automation series. As I mentioned in my recent Reolink videos, I received two Reolink cameras, the RLS522 and the E1 Zoom, to cover how these cameras can be integrated in third-party application. And in this third-party application series, I will be covering Node-RED. I think I've covered some of these scenarios in the past because I had a video how you can integrate IP cameras with the Google Home device, so you can show the picture from your IP camera on the Google Home. So I'm going to go through those scenarios, and I'm going to take you through a few more other scenarios. But basically, this is all going to revolve around how you can take a still image from Reolink cameras, how you can also take a snapshot of a moving picture, like an MP4 recording of a moving picture, and how you can use some of the Onvif functions that the cameras support. So in particular, we are going to see that you can get the camera image as well, but you can also on certain devices listen to events that are coming out from the camera, and I was able to use these to capture the motion detection on the camera, and that would send me an event to Node-RED. So I think that is actually quite useful. And I was able to also control the camera from Node-RED. So the PTZ control, so pan and tilt the camera, and also use the zoom functionality. So these are the things that we are going to look today. And just like in some of my recent notes, I leave quite a lot of comment notes in my flow. And if you double click on these comment notes, I usually leave some additional information there. So links to websites that Reolink has provided or some other websites, you are going to find in the comment notes. And before I dive into the details, I just want to leave as a reminder that all the functions that I'm going to talk about now, so capturing the still image, the video, and the Onvif functions, are only supported to a subset of Reolink cameras. I think the easiest way to remember is, well, obviously you can read the articles that I left a link of in the comment section, but anything which is battery operated is not going to support these functions. So for example, the Argus or the Argus 2, or as you can see, the older E1, E1 Pro, or for example, the Lumus. So you really need some of the traditional cameras that are either Wi-Fi or Ethernet or Power over Ethernet versions. So those are the ones that you can use for these functions. Unfortunately, none of the others support these functionalities or these features. Maybe they will do in the future, but not at the moment. So let's start with the image capture or the snapshot capture. And again, you can read about the the article here that I'm also using to determine how it needs to be done. And for some of these functions, I'm going to save my images to like a special folder on my Pi, which is set up as the static folder in settings.js. So you need to do these changes, and then if you copy anything to those folders on the Pi, you would be able to view them or access them via the Node-RED web server like this. So if you need that one. So the first is, let's capture an image from the camera. So I'm going to use the RLC522, which is looking at my backyard, so the side of the house and some leftover construction material, so not an ideal place. So if I click on this inject node, it's going to request a new image from the Reolink camera, and then you can see here. So let's look at this flow in detail. The inject node is just a simple inject node, there's nothing really here. And then this is a simple HTTP request node, and in this HTTP request node we have to provide a URL, and how the URL looks like, it's actually listed in here. And for this you need to know the IP address of your camera, and you can get the IP address of the camera from the Reolink app, but because you would need to specify the IP address here, I think it would be ideal if you can set a fixed IP address for the camera. And the only other thing that you need is your user ID and the password in here. And that's what you provide here on the URL, and then you leave everything else as basic. Oh, in the return you say that it needs to return a binary buffer. First of all, I have this image preview node. Again, the name of this node, I left it here, so it's a node-red-contrib-image-output. You can install it from the palette manager. And if you provide a payload, which is an image, it can show you on the dashboard. And sometimes I like to do this, that you can check things in the editor. You don't have to go into the UI just to check what's the content of the image. So this is absolutely optional if you want to use that. but you can preview the image. Or what you can do is, the easiest way is you convert the binary buffer which comes out of this HTTP node into a base 64 string. And oh, by the way, yeah, this is not a standard component as well. So I just need to find, yeah, this is it. And I also add it here. Okay. So that's the node for the base 64, and I pass it to a template node where you can specify what, width and height the image should be displayed. And of course the image source is going to be the base 64 data stream, or whatever it's called, which is coming in a payload. And then you just pass it into a template node which displays it on the dashboard. So you can see it here. So that's the image. I mean, of course it's scaled down, but I mean, sometimes I don't want a huge image on my screen. And what I really like about this particular flow, it passes the information directly into the dashboard, so it doesn't save it on the drive. So if you want to do it quite often and you are conscious about wearing your SD card, you can use this flow because it doesn't create a file. But what happens if you want to create a file? So for example, I have the same inject node which just injects the timestamp, and I have the same HTTP request node, and then the output of this is also set to binary buffer, and the output of this goes into this function node, which the only sole purpose of this function node that it generates a specific file name. So as you can see, it will create a file name which is called snapshot _, and then it will pass on the year, a month, date, hour, minute, and second .jpg, and it's going to put it into the /home/pi folder. And of course, this goes into a file out node, and that's just going to write the content into a file. So if I call this one, then as you can see, it created the snapshot file. And if I go to my dashboard and I use my file browser that I covered in a previous video, then hopefully we can see the snapshot file being created here. And if I look at it, that's my image. Yeah, it's the current image. So you can use it like this, and for example, you can use this flow if you want to, for some reason you want to create images, maybe every hour or every day. You just want your Node-RED to automatically create these files with a separate file name and then put it onto your drive. I actually did that for a couple of months with one of my earlier IP cameras, and I use these images to create a really fast video which basically shows how the seasons change and the leaves come and go and that sort of stuff. So I mean, that was gimmick, but you probably find the better use case for this type of application. If you have seen some of my earlier videos, then you know that I'm using Telegram quite a lot. One of my favorite use cases is that I grab the image from the IP camera, which is looking at my front yard. So when somebody rings my bell, I can see who that is. I get a snapshot on my Telegram account on my phone, so I can tell whether it's a postman or somebody else. And this flow starts exactly the same as the one above, so the inject node and the HTTP link. And this time we are saving the image to a file. With Telegram, we actually have to save it to a specific file. So I'm saving it to this file. I mean, technically it can be anything else. And then I can create a Telegram message in a function node. So the Telegram message is a special payload which contains a chat ID. So here you have to put in your own chat ID. So that's the chat ID for your account. And then the type is photo. The content is the path for the image. And you can also add a caption. So besides other things, this is how it's going to look like on the phone. So, I mean, of course, I'm getting some extra messages as well, but this is how a picture message looks like. And of course, you can click on the picture and you can see the image in full screen. So I think this is a fairly useful test case, especially if you are using Telegram in your home automation. And of course, if you are not using Telegram, probably the other most common things to use or send notifications to is via email. So again, I have an inject node. I have the very same HTTP GET, and then it goes into a change node, which is setting a few things to the message.payload. For example, I'm setting the message.to, which is the email address you want to send to. The payload is the email body. The topic is the email subject. and you are also setting this attachment.filename, which is the snapshot.jpg, and that's actually the file name that will appear in your email client. Oh, and I almost forgot the top few changes. So I'm creating an attachment array where the attachment.contents is the payload and the file name is the snapshot. So this is how you pass a file name attachment to the email node. And all this information goes to a simple, email node, which I've configured so it sends the email to my Gmail account. Well, actually from my Gmail account to my Hotmail account for testing. So if I click on this one, it requests and then it sends the email out. And if I look at the email, this is how the email looks like. So you can see the subject, the body, and then the email, and the attachment is called the snapshot.jpg. But what happens if you want to send out an email which actually contains multiple email attachments? In here I used one single camera image, but let's say you detect motion or your alarm goes off or something happened and you want to send a snapshot from your camera, but then you also want to follow it up with a second and a third snapshot, maybe 10 and 20 seconds after. So this is what this follow is going to do. So you click on the timestamp here, and then it's going to fire off the first request to get the first image, and then after 10 seconds it requests for the second image, and after 20 seconds it requests for the third image. And then this node, this function node, keeps collecting these images, and once the third is received, then it's going to send out the email. And just like before, you use this change node to set up the email, let's say the subject, the email body, and the to email address that you want to send the email to. And then in the function node, you don't really have to understand how this function node works. The only thing you need to remember is on the first line, you can set how many images this function node should wait until it sends the email out. So if you want 5 emails, then just change it to 5, and then just make sure that your flow is going to generate 5 images. And of course, it doesn't have to be 5 images from the same camera. You can have from this inject node, you can fire like 5 separate HTTP node from 5 different cameras, so all 5 cameras will get collected into a single email. And if you look at the email, that's how it looks like. So we have snapshot 1, snapshot 2, snapshot 3. I think this is also a fairly good use case how to use these cameras and the email functionality. And of course, if movement is detected, you probably want to have just a few images in case the first snapshot misses the the subject. And with this, I think we have covered all the the image processing capabilities. Next, we can look at how we can process the video stream. And to process the video stream, I also have a few links that I can recommend. So first of all, there is a link from Reolink how you can get the RSTP URL for any of the Reolink cameras. Again, the caveat is that it's not supported for all these cameras at the moment, but basically it's this is the URL for the mainstream. Again, you need the IP address of the camera, and you need the admin user ID and the admin password. Well, the admin user ID is admin. And you need a password in order to access the RSTP stream. And for these examples, I'm just going to use the main stream, but you can also use the substream, which is the lower resolution stream. And to do the conversion of the RTSP, I'm always saying RSTP, but it's the RTSP, real-time stream protocol. So in order to convert this feed to an MP4, you need FFmpeg. And usually you can install FFmpeg like this in a Raspberry Pi, but I'm using I think I'm using Raspbian Jessie for some reason. I mean, this Raspberry Pi has been running for such a long time now. And for Jessie, for some reason, FFmpeg is not available. So you can use this link to look at this discussion, and you use post 7, which is going to give you a link how you can install FFmpeg on Raspbian Jessie. The process is going to be very simple. The heart of the logic is actually in this exec node. So this is going to call the FFmpeg to convert the stream into a video. And that's the full URL. I just wanted to copy it to a notepad so we can see. So it starts with FFmpeg and these flags. And then here after the -i, which is the input, you specify the RSTP stream. So that's the RSTP stream for the camera, of course, with the the user ID, the password, and the IP, which was on this article. And then you have all the additional parameters. Probably the only thing that worth noting is this -T60, which basically says that it's going to do the conversion for 60 seconds. So it's going to convert 1 minute of footage from the live stream into an MP4. And of course, the only other thing we need to add at the end of this command is the file name that the MP4 needs to be saved at. And the way I do it in my flow is I have a simple change node where I put the the path for the MP4 into the payload, and that gets appended to the end of the the command here in the exec node. So at the moment it's triggered manually, but if I just trigger it, then FFmpeg starts, and now it's going to run for a minute. And when it completes, then we should be able to see the file in the dashboard. So I can click on this open video link and I will be able to, download the video. And we just have to wait until this disappears. And besides that, I also wanted to show you this stream. And this was an example that I've downloaded, and it appears to be, it should be doing the very same thing as the video capture, but for some reason for Reolink cameras it doesn't really work. So you're supposed to click on start streaming, and maybe I shouldn't do that while still doing the conversion, and you would be able to see the live feed here in the image preview. But probably because how Reolink creates the RTSP stream, for some reason it's not working, so you're always getting this invalid source message. But I mean, to be honest, I don't see a lot of value looking at your live feed in your editor. I left this in so you can play around with it if you want to, but I think the main use case is going to be this anyway. So for some reason you need to save the recording in the MP4, and then of course you can click on here. Oh yeah, sorry, this is my other camera which is in the kitchen, which for some reason is looking at my water jug. But anyway, you can see that the time passes, so it's actually doing a 1 minute recording from this camera. Well, at least now you can see that it's working on the E1 zoom as well, not only on the RSC522. And when this completes, you have an MP4 file on your Raspberry Pi. So again, you can just put it into an email. You can put it into a Telegram message. It works exactly the same as the JPEG example we have seen. The only difference is that instead of a JPEG, you are just linking the MP4 file. Of course, keep in mind that this file could be quite large, especially if you are converting the main stream. So maybe you can use the substream, or you can reduce in the -T60 parameter, maybe you can just reduce it to -T, I don't know, 20. So it's only going to be a 20-second recording. And with this, we reach the end of the still image and the video examples. So now I'm going to go into the Onvif support. And in case you don't know that, because, well, I also had some vague memories what Onvif is, but this is an interface specification that are usually adopted by many camera makers. So if your application supports Onvif, you would be able to talk to many different cameras from many different vendors, because they would start implementing the same functions, like, discover the cameras, ask for the picture, ask for the different URLs for the video stream, and, listen to events, that sort of stuff, or use the PTC function. So here, that's the article from Reolink on what cameras supports the Onvif and what profiles they support, because there is a lot of function in Onvif that these cameras actually don't support, and I'm going to come to that in a few minutes. And in order to use these functions, there is a set of nodes which is being developed by Bart at the moment. And these nodes are available on GitHub, but they are not part of the NPM, so you won't be able to install it from the palette manager. So I recommend that you go to this GitHub page, and actually there is a tons of information here, and there are a lot of example flows here in the README. So as it says here, this is an experimental Node-RED contribution at the moment, so that's why you can't install it easily. So you just have to install it manually in your Node-RED folder, and then of course you have to start Node-RED. But once you've done that, you would be able to use all these functions. And to be honest, I have implemented most of these in my flow. And if I zoom out a little bit, and if I scroll to the right, you can see all the examples here. but I've actually only used a few of them in my flow, and well, I'm only going to share a few of them because, as I said, not everything is supported by Reolink, unfortunately. So I was trying to focus on the ones that are actually supported, and I think they're worth investigating. So first thing first, which actually I haven't included in my flow, but you can see that all these cameras support a discovery function. So you can send out a request on your network, and all these cameras will start reporting back that, oh yeah, I'm here, I support this function. And if I do this in my network and I start the search, so again, this example code is coming from this site here, it's actually this one. You can see that I got response from 4 cameras, and I only have Reolink cameras, so these are all Reolink cameras. And of course, I'm not getting response from the Lumus or the Argus 2 because those are the ones that don't support Onvif. So if you are unsure what cameras you have, you can use this discovery function, and whatever comes up here in the discovery, then those are the ones that you can use in the rest of the flow here. So let's look at the first Onvif function that I highlighted, which is the snapshot image. And this does exactly the same thing that we just did above. So you do an inject node. Instead of using the HTTP request, you use this Onvif media node, and then the output you get an image. So you can really decide whether you want to use the HTTP method. You can use this method as well. They are perfectly interchangeable. But if you would only use this functionality, you can just use the HTTP request and you don't have to install these additional Onvif nodes. So this is the image capture, and as I said, it works fine. The next one I wanted to highlight is the device events. And device events can be used for a lot of different things, and some cameras even send out statistics on the device events, like what is the CPU usage, like, I don't know, memory or voltage or whatever. It looks like that Reolink doesn't really do that, but one thing I discovered, some Reolink cameras can send you motion detection information. And out of the out of the 4 cameras that support Onvif, I could only get it working on sort of the fixed camera, so the 420, the 420W and the 522. It doesn't work on the E1 zoom for some reason. And the way it works is you set it to start listening, and it starts listening to events. And then whenever event is received, as you can see, that it's going to send back a fairly complicated object, and this object is going to identify that the event is a motion detection event, and it also has an attribute which says is motion, so if motion is detected, which can be either true or false. So what I found in the 522, that it sends an event when the motion is detected, and then it also sends an event when the motion is no longer present, like I move outside the view of the camera. And also what I noticed is that the motion event is actually getting sent multiple times. So if I just keep moving in front of the camera, then it will send the motion event, let's say, I don't know, something like twice a second or something like that. So what I do is that if I have a motion, I just limit the number of messages to 1 per hour because I don't want all of the messages, and I take a snapshot and I put it onto the dashboard. And once the motion is no longer true, so the motion is gone, then I take another picture as well. And I also update this motion status on the UI as well. So hopefully what's going to happen is I would have a snapshot of, once somebody got detected, and also a snapshot when that person has moved out the frame. So now I'm outside, I'm going to the back of the house, to the 522, and then hopefully motion is going to get detected. And I'm also looking at the live feed on my phone. So I'm moving into the frame, and hopefully motion is going to get detected. And there is a lot of backlight here. Hopefully that's not going to fool the camera. So come on. Oh, motion is detected. Okay, let's go back and look at what happened in Node-RED. Okay, so hopefully you can see that this was saying motion at some point, and I got an image when the motion was detected, and I also got an image as I was walking out of the frame. So it was definitely working. That's definitely a good sign, because I haven't rehearsed this quite a lot. And these are the messages that we have received from the RSC event. So you can see that it has a topic, and then it also has a time and then some property. But here in the data, it says that the data is motion and the value is true. So this is when motion was detected, and the last message should be showing me motion is false. And the other interesting thing is that this functionality was working slightly different with the 522 and I think either the 410 or the 410W. So for example, the 522 is sending me an event when motion is no longer detected, but some of the other cameras don't do that. So just be aware of that. Make sure that you test the cameras and then see how they are working. And of course, if you don't want these events anymore, you can just stop listening to these events. I'm a little bit disappointed I'm not getting, more events, but to be honest, the motion detection is probably the most important one anyway. So you can use these start and stop events to, let's say, also limit when you are receiving these messages. Let's say you turn on your home security alarm and then you start the event listening on your cameras, and you can collect all these motion triggers, and maybe you can just save the images yourself locally, or just send them over to Telegram, so you don't have to pay attention to the Reolink app. But it works nice, and it seems to be working very reliably. And again, I've tested with these other cameras as well, except the E1 zoom where it wasn't working with. But again, maybe with a future update in the future, this feature is going to work on the E1 zoom as well. And finally, let me talk about the PTZ functions. You would be able to control your cameras from Node-RED as well, as in pan and tilt them and use the zoom. So I'm quickly going to demonstrate it in the 522. So I have some injects node here in the editor as well. I also have some buttons in the UI. And in the change rules, we are just setting an action, which is the continuous move. And there is also some speed, which controls how fast the movement is. But I don't think in the Reolink cameras, the speed of the movement is actually implemented. So you can just put any values here. I mean, of course, positive values means zooming in and negative values means zooming out. And the same applies to all the motions as well. So I think positive is up, negative is down, and positive is left and negative is right, or vice versa. But you can look at the code and see how it works. So let's look at it for the RSC 522. So I have the controls here as well, and you can see the live feed from my phone. So if I click on plus, then it zooms in. We can see it on the live feed. And if I click on minus, then it zooms out. And because it's a continuous zoom, you could use the stop button to stop zooming at any point. So you can't make it to zoom 10%. You have to send a zoom command and then a stop command to stop, unfortunately. And let's look at the E1. So I can make it to pan left, and then I use the stop button to stop, and I can make it to pan up and stop, and maybe pan down now, and then stop, and I can zoom into this one as well. The one thing I really regret is that in Onvif there is a lot of different movements supported. So for example, many cameras support a home function. So let's say in the E1 zoom example, you can set up a spot, like a particular location and zoom a level that is the home function. And then you can just tell the camera to move to the home function. So it would automatically pan, tilt and zoom to the same location. And that is not supported in these cameras. Also in Onvif, there is an option to support presets. So again, you can move, for example, this E1 to various locations and set them as presets, and you can just call up those presets and it would automatically move to those locations. That is not supported either. Also, there are more functionalities about moving. So at the moment, I'm using this continuous move action. There is also options to use absolute move and relative move, which again, I think it will be quite useful, because then let's say I can home the cameras in the upper right corner and then use the absolute move or the relative move to move to a certain area of the screen. So this is how I could, go around the fact that it doesn't support presets, but that is not supported either. So the only option you have is start the camera moving in one direction and then you send the stop command. And I mean, it certainly works, but it's probably not good enough to automatically move to certain parts of the screen. If you are doing with no dread, sort of like unattended, then you can just sort of like move it, pan it to, or tilt it to all the different extents. Maybe if you use the delays, you can sort of like make it to, you know, follow a particular pattern, but I don't think it's going to be, you know, very accurate. So these are the functions that you can use, and based on my experiments and, you know, trying out all these, it looks like that none of the others are supported at the moment. So maybe that is coming in the future as well. So these are all the use cases that I managed to cover for the Reolink cameras, and well, the use cases that I think actually make some sense and you can use it to certain scenarios. So image capturing, the video capturing, the event logging or the event monitoring, and the PTZ functions. As always, if you are interested in this flow, you'll find the download link in the video description. And I just want to stress enough, again, don't forget to look into the comment notes, because this is where I put most of the information for, you know, the various subcategories or various subflows. But that would be all for now. Thanks for watching, and hopefully see you in the next video.